Welcome back to geometry. Today we're going to get ourselves started on chapter 11. The entire chapter here is going to deal with two basic geometric measures. We're going to be looking at perimeter a little bit and area a great deal. All right, those are going to be the two measures that we're going to focus on. All right, perimeter and area. And we'll start off with three postulates. As I move forward, just keep in mind, if I'm moving the screen too fast, please remember just pause the video whenever you need to make sure you get everything into your notebook. But we'll get ourselves started with three postulates, numbers 24, 25, and 26. Postulate 24 gives us a formula for the area of a square. The area of a square is just going to be the length of one of the sides raised to the second power. The length of one of the sides raised to a second power. So just make sure you notice the power there. Okay? 25 and 26 aren't very important, but there they are. 25, congruent shapes have equal areas. We don't use that one very often. And then 26 we do use occasionally. The area of a shape is equal to the sum of its parts. And before we're done in this video, I'll give you an example of using postulate number 26. Okay? Next, we're going to have three theorems that talk about areas of basic shapes. Now, I know you've seen these before, but just get them into your notebook one more time. Theorem 11.1 gives us the formula for the area of a rectangle. It's just simply the length multiplied by the width. Now, please remember a rectangle is any four-sided shape with all four angles being equal, which of course implies all of the angles have to be 90-degree angles. And then a result of that is that the opposite sides of a rectangle are then going to be equal to each other. Okay, so just a quick reminder back from when we're looking at quadrilaterals. Length is usually, we consider the longer side, and width usually the shorter. Doesn't really matter, but those are the two sides. And then the formula just says the area of a rectangle is the length multiplied by the width. Just the condition, the length and the width have to be perpendicular, which makes sense because all of the angles are 90s. Okay, theorem 11.2 gives us the formula for the area of a parallelogram. And the area of a parallelogram is the base multiplied by the height. Again, the condition, when we use the word height, those two have to be perpendicular to each other. Okay, and this is a little bit trickier because normally, not always, but in most parallelograms, we don't have 90-degree angles, right angles going on. So the height is usually got to be an extra line drawn within the picture. We usually have to have an extra measure given to us that is perpendicular to one of the sides. So as an example, here we might need to be given h, the height, perpendicular to the b, base. Okay, and then the formula is just going to be base times height. All right, and finally, the third basic formula for areas is going to be for that of a triangle. Area of a triangle is 1/2 multiplied by base multiplied by height. And again, please notice the base and the height have to be perpendicular to each other. Now, because we have three types of triangles classified by their angles, we have right triangles, we have acute triangles, and we have obtuse triangles when classified by their angles. Now, the nice thing about a right triangle is we already have a 90-degree angle. So in that case, we normally consider one of the legs to be the base and the other leg to be the height. Those would be the two that form the 90-degree angle. But in an acute triangle, there is no 90-degree angle at any of the vertices. So what we traditionally have to be given is a fourth distance, a fourth measure that's perpendicular to one of the sides. So as an example, if I drew a perpendicular in as you just saw, then the height is going to be the perpendicular drawn to the base. Okay? And the weirdest one is when we have an obtuse triangle and we want to use, as an example, this side as the base. Then how do we draw a perpendicular to that base? Well, what we actually have to do is extend the base past a vertex. So it's kind of like we're creating an exterior angle. But then we're able to drop down a perpendicular from that opposite angle, and that becomes the height. The key is to remember that we don't need to worry about this extension. We don't need to worry about that extension. We don't need to use that or think about that. We still just use B the way it was, and then H. Okay? Alrighty. So I'm just going to buzz through a few problems finding areas, and then we'll do one with perimeter as well. But here's a rectangle, and all I would ask you guys for is, hey, what's the area of the rectangle? Rectangle, you know, because we have 4 right angles, and so therefore the formula for area is going to be length times width. The length of our rectangle is 16, the width is 6, therefore the area is going to be 96. And please remember, we measure perimeter in just standard units like inches, centimeters, meters, and so on. But area is measured in square units. So this would be 96 square inches. Okay, how about the square? We'd have to go back to one of the postulates. The formula for the area of a square is the length of one of the sides squared. So in our case, one of the sides is 11. So 11 squared is 121. Again, area is going to be measured in square units, so it'd be 121 square centimeters. All right, how about a parallelogram? A parallelogram area is going to be the base multiplied by the height, but remember these two folks have to be perpendicular to each other, so you're not able to, you can't use the 10 because the 10 is not perpendicular to anything. But what we can do is use the 8. So the area of this parallelogram is then going to have a height of 8, and I just need you to remember that opposite sides are equal. So if the top is 14 millimeters, the bottom would be 14 millimeters as well. So the base, 14, and the height, 8. And then when we multiply those together, let's see, we get 112, I believe, and the units would be raised to the second power, so 112 square millimeters. Okay, next we have a right triangle, and because we have a right triangle, we have a 90-degree angle. The area of that triangle is going to be 1/2 times base times height, but again, remember base and height have to be perpendicular to each other. So in this case, the base is 12 and the height is 5. So when we do the computation then, we would get an area of 30 square feet. Okay, a couple more triangles, just to make sure we kind of see one of each type of classification. Here's a triangle that would be acute, and so again the formula is going to be 1/2 times the base times the height. And the way I've drawn this one, the base is going to be 13, and then the height is going to be the perpendicular to that base, which in this case is 5. And when we punch that out, 1/2 times 13 times 5, let's see, I'm going to write that as a decimal. So 13 times 5, so we get 32.5, and we're in inches here, so 32.5 square inches. And then finally, the area of an obtuse triangle, again, 1/2 times base times height. And notice where the 90-degree angle happens, so we have to use the base of 16. Again, we don't need to worry about this extension. Don't need to worry about that. We just use the 16. And then the perpendicular is 12. So 1/2 times 16 times 12. What does that get me there? 96, I think, if I'm doing that okay in my head. So 96 square meters. Okay, so that's an example problem with each of our basic shapes and then each of the different types of triangles we could have. Now I'm just going to change up on you a little bit. I'm going to ask you this time to find both perimeter and area. So here we go. Given the hypotenuse of a right triangle is 40 inches and a leg of the triangle is 24 inches, find both the perimeter and area. So I'm just challenging you to also remember what perimeter is on this example. Now I'm starting you off with a right triangle. So just for the purposes of somewhere to attach some numbers, just draw yourself a basic right triangle. Doesn't have to be accurate, just draw a basic one. Then I tell you that the hypotenuse is 40 inches, so across from the 90-degree angle, 40 inches. And then one of the legs is 24. Doesn't really matter which one's which, so just attach 24 to 1. Okay? Now what I'm going to ask you for is the perimeter of the triangle. and I'm going to ask you for area of a triangle. Now area we've already talked about today, so that's 1/2 times base times height. But perimeter, I just need you to remember, is just the sum of the three sides. Okay? And so this perimeter is going to be one side, 24, plus another side, 40, plus the third side. And we don't know what the third side is yet. Okay? So to find that third side, to find that missing side, let's initially call it question mark. How do we find the missing side of a right triangle? Pythagorean theorem. Again, I've already indicated the hypotenuse for you guys. So Pythagorean theorem would be leg squared plus leg squared equals hypotenuse squared. And let's punch out a little math. 24 squared is 576. 40 squared is 1600. So I'd have to move 576 to the other side by subtraction. We get 1024. And then when I get rid of the power of 2 by taking the square root, the missing side then is going to be 32. So our missing side then would be 32 inches. Therefore, we now know our third side, and the perimeter is going to be 24 plus 40 plus 32. And let's see what we get there. We get 64, 94, 96. So the perimeter would be 96 inches. Remember, perimeter is just distance around. Okay, and then the area is going to be 1/2 times the base times the height. But remember, these two folks have to be perpendicular to each other. So where's the right angle? And then the two sides that are perpendicular to each other are the base and height. So the area then of the triangle is 1/2 times 32 times 24. So we get, as a result, 384. All right, and please notice perimeter is measured in just plain old units, inches, but area is measured in square units. So please make sure you make note of that for yourself or put that into your brain. So as we move forward, you remember how to give me the correct answers. Okay, then just a couple other example problems and then we'll call it a day. If I give you this shape on a, on a two-dimensional system, an XY coordinate system, can you guys help me get to the area of that shape? Okay, you might recognize this shape from a couple of chapters ago. This is a kite, and it's going to be a kite because these two sides are equal, they're adjacent to each other, and then these two sides are going to be equal, they're adjacent to each other. So this is actually going to be a kite. But that's not what I'm asking you about this time. Here I'm asking you to calculate the area. All right, and since we don't yet have a formula for a kite, we will soon, but we don't have one yet, how can I do that calculation? How can I find that? And the answer is, I start by taking the kite and dividing it into two shapes that I know. And I could do it in a couple of ways, but I'm going to choose to do it this way. I'm going to choose to do that by drawing a line between D and B. And what two shapes do I create? Well, I create a triangle up here. I'll call it T1, triangle number 1. And then I create a triangle down here that I'll call T2, triangle number 2. All right, I create a triangle above and I create a triangle below. So now using the third postulate, number 26, the area of a shape is equal to the sum of its parts. So all we're going to say is the total area of this kite is going to be equal to the area of the top triangle plus the area of the bottom triangle. We just add those two folks together. So the total area will be area of triangle number 1, 1/2 times base times height, plus the area of the second triangle, 1/2 times base times height. All right? And so because it's on a two-dimensional coordinate system, we can see the base and the height of the triangles. Let me use my laser pointer here. The base of the first triangle is going to be the distance from D to B. So just count them up. That's going to be 1, 2, 3, 4. So the base is going to be 4. And then the height of the triangle, the perpendicular height, is just going to be 1 block or 1 unit long. So that's going to be a 1. Okay? And if you want me to, I can just get this over with and punch out this math. 1/2 times 4 times 1 is 2. So the area of the top triangle is 2 square units. Now the bottom triangle, and let me choose my laser pointer, we have to find the area by multiplying 1/2 times base times height. The base is still going to be the same. It's going to be 1, 2, 3, 4 long. But this time the perpendicular height is going to be this measure. Right? So counting up the blocks, it's going to be 1, 2, 3, 4. And when we do the computation, 1/2 times 4 times 4 is 8. So just simply multiplying the area of the top plus the area of the bottom, 2 plus 8 is 10. So the area of this whole shape then is going to be 10 square units. Now when we're not given inches, centimeters, feet, whatever, we just use the generic label units. So it'd be 10 units squared. Okay? All right. And then we'll just finish off with one more example. Oh, nope, sorry, I've got two, my bad. We've got two more examples. First, find the area of this arrow. Can you help me find the area of this arrow? Using the same idea of the area of a shape, like this arrow, is going to be equal to the sum of the areas of the parts. So all we need to do is cut this into shapes that we know. And there's all kinds of different ways to do it, but here's probably the easiest. If I make a cut here, that creates two shapes, a rectangle here and a triangle here. So all we need to do to calculate the area of the arrow shape is just then think of this as the area of a rectangle plus the area of a triangle. And we know how to find each of those. The area of a rectangle, the area of a triangle, we know how to find each one of those. All right, so let's go ahead and do it. What's the area of a rectangle? It's going to be the length multiplied by the width. And you can see both of those measures clearly on the picture. The length of the rectangle is 28, and the width of the rectangle is 16. So you can clearly see both of those, 28 and 16. And when I punch that out for you guys, let me use my calculator. 28 times 16 is 448. So this first area for the rectangle, 448. Now we need to find the area of the triangle. And the area of a triangle is 1/2 times the base times the height. All right? So how can we find all of that? Well, if I could, let's see, let me choose this eraser. I think I can get rid of where it says TRI, because obviously you guys can see it's a triangle. But now I can draw in a few lines. The base of the triangle is actually going to be this line if I extend where we cut. And can you guys see what that measure is? Well, it's going to be the same as the measure on the outside of the picture here. That total measure is going to be 32. And then the perpendicular height, let's choose to draw the height this way. Let's choose to draw the perpendicular height that way. Can you guys get me that length? Well, using the laser pointer here, if this whole distance left and right is 42, but then the length of the rectangle is 28, what does this piece have to be? Well, it's got to be 28 plus this piece equals 42. And that makes this distance then 14. So the base of the triangle would be 32 and the height would be 14. And then we just need our calculators. 1/2 times 32 times 14. So again, I'll just calculator that up for you guys. And we get 224 there. And so when I add those together, the area of the rectangle plus the area of the triangle, we get, if I punched okay, I got 672. And again, if we don't have units given in the problem, just to please attach square units to that answer. Okay? All right. And then we're just going to have one more and then call it a day. Just create an algebra problem out of a geometry problem here. If I were to give you the parallelogram below, and I actually tell you what the area is, could you guys find the value for x? X here happens to be the height. Could you guys do that? Sure, it's not going to be too bad. we just have to start with the formula for the area of a parallelogram. The area of a parallelogram is base times height. Remembering these two fellows have to be perpendicular to each other. And the thing that's a little different here, instead of finding the area, we're told what the area is, so I can replace A with 104, and then you can see from the picture that the base is 16. And so the only value left then is the height, but that's what they're calling h in the problem. So how would you solve for x? You get rid of times 16 by division, and so x is going to be 104 divided by 16, which is 6.5. So the value for x then would have to be 6.5 meters. Okay, so that's all we're up to here in this first section, is just taking some basic shapes, squares, rectangles, parallelograms, triangles, and finding some mainly areas. And then there'll be a couple of example problems you'll see where we also need to find perimeter. Okay, so after you shut this video off, go ahead and give the problems in this section a try and see how you do. All right, let me know if you have any questions. Otherwise, have a great day. Bye.